Okay, YouTube, this is my sixth and last video on my module on factoring, in which we're going to look at factoring involving fractional as well as negative exponents, which freaks people out. But what I want to kind of bring up here is we're just going to use our basic factoring methods, which are look for greatest common factors, how many terms does it have, use special factoring patterns, and can we keep factoring? So basically, let's go ahead and take a look at these two examples I have here. I'll work you through them and you kind of see where I'm going with it. But the first thing I want you to understand is that when I look at this here, the first thing I'm supposed to be checking for is the greatest common factors. This is a sum of two terms. We've got a term here, x times this and a -3/4 and plus x, to the 1/4. Okay, right. Basically, I notice that these have a common factor, x plus 1. So what we're going to do is we're going to factor that greatest common factor out front. As a matter of fact, I'll just make it really easy for you, x plus 1. The question is, since these have negative exponents as well as, rational exponents, what the heck do you do? And so my suggestion is always going to be this. You factor out the one that has you factor out the exponent that is the lesser of the two exponents. So I say, well, -3/4, 1/4, what's the lesser? That one, -3/4. So we're going to factor this -3/4 one out front and talk about what's left. One thing I do know is because since we factor this out front, we're dividing it out of everything that was left. This is no longer going to be there, and all I'm left with really is this x. And also I'm going to have a positive here. That's just the same positive that I'll wrangle from up there and drag it down here. As far as what's left here, now I had 1 times this quite technically. So when I say what is left here, recall that when you factor something out, you are dividing out what was already there. And if we were to observe, what if I took x plus 1 to the 1/4 and I divided it by x plus 1 to the -3/4? Using our rules of exponents, okay, we get x plus 1 to the 1/4 minus -3/4. So 1/4 minus -3/4, well, the nice thing for you, actually, if you think this is brutal, is that you already have a common denominator here. So what you get left with is x plus 1 to the what? Well, 1/4 plus 3/4 is 4/4, and 4/4 is x plus 1 to the 1. So really what's left here is we get x plus 1 here. And I'm going to rewrite this even further. We say x plus 1 to the -3/4. And this is all times x plus 1 is really 2x plus 1. Okay? And if we wanted to simplify this further, which we probably should, it'd be 2x plus 1 over x plus 1 to the 3/4 positive. But I'll tell you this. For right now, this is what we're looking for. We were trying to factor it, and I was able to rewrite it as a product, right? Remember, we're trying to write the sum as a product. So let's try this tact again over here. Again, I notice two terms, each one containing an x minus 1 to some power. So what I'm going to do is I'm going to factor out the x minus 1 out front. We say x minus 1. X minus 1 to the what? Well, if you were listening, right, we say we're going to take the lesser of the two exponents. So I'm going to take out this -1/2, and let's talk about what's left. Again, this is no longer going to be there because x minus 1 to the -1/2 divided by x minus 1 to the -1/2 is 1. So really all that's going to be left on this first term is the x plus, and we'd say, well, what is x minus 1 to the 1/2? You could think about it, but I'll write it out here. -1/2. We're going to get x minus 1 to the 1/2 minus -1/2, which is to the 1. Okay? That part, at least. I should say this, x minus 1 to the 1. So what we get is just x minus 1 to the 1. So the complete factored expression here would be this. We say -1/2, and this would be times 2x minus 1 on the inside here. And here's our factored expression. Cheers.